So chapter number 6, guys, we're going to talk about thermodynamics in this chapter. Okay. Now, guys, can anyone tell me what does the word thermo mean?
Temperature.
Thermo means heat. So temperature or heat. So it means heat. What is the word? So the word dynamic here means that it can move or transfer. Okay, that it's mobile. So dynamic. That's what dynamic mean here. So the other word for thermodynamics is basically heat transfer or heat movement. So in this chapter, guys, we're going to learn two different ways in which the heat can move. Okay, so what we're going to see is, first of all, guys, heat is, let me write that again. So guys, heat is a form of energy. Okay, and energy is of course the capacity to do work. It could be a capacity to do work or the capacity to raise temperature. Okay, all right. Since, guys, we are talking about energy and heat is actually a form of energy, can you guys tell me what are the units for energy? The heat will have the same unit if you can tell me the unit for energy. You guys here? All right. So, guys, the unit for energy, guys, what's that?
Fahrenheit.
Say that again.
Fahrenheit and Celsius.
So
And
Fahrenheit, Celsius, those are units for temperature, right?
yeah.
Like Celsius, Kelvin, Fahrenheit. Those are units of temperature. Like if you want to measure how hot or cold something is, then we use a thermometer and you measure the temperature from there, which is an indirect way to tell how much energy something has. But what are the units for energy itself? Now I'm going to give you guys a hint, okay? And this should click. So when you eat something, what do you count?
Calories.
Calories. So calories, that's the unit of energy. Okay. Now, those calories, of course, can go into your body and then you can do the work for them, right? You see the capacity to do work. The food gives you the capacity to do work, or it gives you the capacity to raise your body temperature. So, calories is a unit of energy. Is there's one more unit like calories? What is that one called? That's also a unit.
Kilocalorie.
What's that?
Kilocalories.
So,
Kilocalories.
calories can be modified to kilocalories or kilocalories, but the base unit is calories, right? It's like saying meters and kilometers is a unit for length. You're right, but there's one more different unit, not calories, but something else. Starts with a J.
Joules.
Joules. Okay, right. Joules. Okay. So joules and calories, guys, they're two very common units used for energy. Joules is more common. I mean, we're going to see in chemistry, we're going to be using both of them, but calorie is more commonly used when it comes to food. So food calories usually are food energy is usually in calories. You're probably not going to find it in joules. But just like any other conversion, we can convert calorie also to joules. And guys, 1 calorie is equal to 4.184 joules. So this is one conversion factor that you should keep handy. You're going to be seeing questions like that on your quiz and your exam, where I'll just give you something in calories, you change it to joules, or I give you something in joules, you change it to calories, okay? So let me just quickly give you one question. Let's say we got 8.50 joules. Can you guys change it to calories? Can you guys do the math, the conversion for this? If you understand conversions from chapter 1, you should be able to do this. So start with whatever is given to us, so 8.50 joules. And remember this conversion thing, guys? And tell me where should I put what?
Joules on the bottom.
So joules I should be putting here in the bottom. And what should I put here on the top?
Calories.
Calories. Now, can you tell me the conversion factor for calories to joules, guys? What's the conversion factor? What number should I put in front of calories?
1.
1. And joules get what number?
4.184.
So 4.184. So you simply just divide these two numbers, and then what do you get when you divide these two numbers? How much?
2.03.
2.03?
Yeah.
Okay. Did anyone else also got that number?
Yes.
Okay. 2.03, and it's calories now, right? Okay. Okay, that's one conversion for joules to calories to joule. Now, one more thing, guys. Tell me, what do you think? 1 kilocalorie has how many calories?
1,000.
1,000, right? You're right. So a kilocalorie has 1,000 calories, right? So calorie is a small unit. Kilocalorie is a bigger unit. 1,000 kilocalories, 1,000 times bigger than calories. Now, as you know, the food calories. So when you guys read the back of any food packet, and then mentions calories, what do you think those are? Which ones? Is that kilocalorie or is that calories in the back? So if, let's say a cookie, a chocolate cookie says in the back it's for one serving it's 100 calories. So 100 calories, is it the kilocalorie or is it the calorie?
Calorie.
Kilocalorie.
It says a calorie, but we have to be careful, guys. They say calorie, but it's actually kilocalorie. For some reason, they don't, maybe just to keep it simple, they don't like to use the term kilocalorie and just the term calorie. And that has been approved by, of course.
But in other countries, they use kilocalories, right?
Yeah, some other countries, yes, yes. I've
Wow.
been in, yeah. So when I, usually Asian countries, they do show kilocalories. They even show joules. Some of them will show joules as well. But
I was like
yeah.
really surprised when it said it that.
Yes, yes. So it's actually it's kilocalories, and that's how it should be here as well. But for some reason, we don't have those. We just want to keep it simple. Maybe that's why. So now there's one way to distinguish them, but again, it's hard to do that again on the back of the packet. But if I say here, guys, 1 kilocalorie, 1 kilocalorie can actually be also written as one capital C. Okay, there's actually even a difference between capital C and small c. So a capital C actually means a kilocalorie, but a small c is the regular calorie. Okay. So 1 kilocalorie, guys, is how many calories again? 1 kilocalorie is how many calories?
1,000.
1,000.
1,000, right? So one of capital C is actually equal to 1,000 of small c. Okay. Right. Now, I'm not going to test you on this capital C, small c, but just for your information, I'm putting that here. Okay. But you will be tested for sure on joules and calories. Okay. All right. Any questions so far, guys? Okay. Now, guys, let's talk a little bit more about heat. Okay. Now, let's actually try to distinguish the word heat from temperature. It's very important that we understand these two terms are different. Okay. So, guys, let me give you guys an example here. Again, tell me, guys, if I have to compare these two, can you tell me the units for heat again one more time?
Calories.
Calories. And can you tell me the unit for temperature?
Fahrenheit, Celsius, and
Kelvin,
Kelvin.
right? So we got, so I'm just sticking with Celsius for right now. That's the most common unit used. So calories and Celsius, you can, first of all, you can just directly see right now that there's a difference between heat and temperature. Their units are different, right? So so heat is basically the energy, the form of energy, but temperature is actually the measure of heat or energy, because heat and energy is the same thing. So if you want to measure that a thing has how much energy saved in it or how much energy or heat stored in it, to measure that, you measure the temperature. Okay, so now actually also see one more scenario where hopefully it'll make sense on what heat and temperature, how they're two different things. So guys, let me give you two scenarios, okay? So listen to this carefully. So there's a drop of oil, and oil, by that I mean the cooking oil, okay? So you have cooking oil at 350 Fahrenheit. And then you have a drop of a 350 Fahrenheit oil, and then you have a bowl filled with oil at 350 Fahrenheit. If you measure their temperatures, which one is more hot? So whose temperature is more, guys? Is any one's temperature more than the other?
No.
No. Both of them I'm saying are 350 Fahrenheit, right? Their temperatures are the same. But if I ask you, you drop a tiny drop of that oil on your hand versus that that bowl of oil, if you spill that somehow, for some reason, then which one do you think is going to hurt you more? A bowl or a drop?
Bowl.
Bowl, right? And why is that? Because but aren't their temperatures are same. Both of them are 350 Fahrenheit. So why is one hurting you more than the other?
Because more
The
power.
Covers more
volume
There's
surface
more
area.
of it, right? Because there's more of it. And by that, what do we mean? It actually has more heat stored in it because there's more mass in there. Okay, is the heat is proportional to the mass. If you got more mass, it will store more heat in it, and that's why it's going to hurt us more. Although both of them were at same temperature. Does that make sense, guys? How heat and temperature are two different things?
Yes.
Okay, so now, guys, let's see one equation that is useful for heat. Guys, heat symbol. What is the symbol for heat, guys? The symbol for heat is Q. Okay. Just like what is the symbol for temperature, guys? It's capital T. Okay. So guys, again, listen carefully. Okay, what I'm saying. I'm not asking you the unit. What is the unit? What is the unit for heat? Tell me that first, guys. What's the unit for heat? We just learned it. It was
Calories.
calories. What is the symbol for heat?
Yeah.
You.
Q, okay. Like for mass, we use the symbol M, right? That's what we mean by the symbol for heat is Q. So let's look at one equation. So Q is actually equal to, we're gonna multiply it by three different things, okay? We're gonna multiply M, C, delta T. Now guys, this, there's something wrong here. Give me a second. Okay. That not save. Okay, let me write that again. So guys, Q is equal to M times C times delta T. Okay, so heat, so Q is heat, is equal to, guys, what do you think M is? M stands for?
mass.
Mass. And delta T is, I think we have seen delta before. You guys remember what does delta mean?
Change.
It means the change or the difference, exactly. So difference or change in temperature, because T, remember, stands for temperature. So basically, we are seeing that delta T is the change in temperature. And guys, this C, we have not seen that before, but the C is called specific heat capacity. Okay, now guys,
That's in lowercase c?
what's that? Lowercase.
That's a lowercase c?
Yes, that's lowercase c. It's also very common, guys, to replace that C with an S. So somewhere you're going to see it's called C, and somewhere you're going to see it's going to be called S. So Q equals MCT, or Q equals MST. The C and S is the same thing. What is C or S again, guys?
Specific heat
The
capacity.
specific heat capacity, okay? All right. So guys, let's first try to break this down, okay? Let's try to understand that why is Q equal to MC delta T? Why do we need these three factors, and why do we use them, okay? So let's take a look at that. So guys, if you're trying to heat something, what are the things we should keep in mind? The first thing, guys, that we should keep in mind is that what are we trying to heat? How much are we trying to heat? And so what is the amount of substance that we have that we're trying to heat, okay? Because I'm getting some background noise from somewhere. If you think you have some background noise, you might want to mute yourself. Okay. All right, so guys, let's get back to this, okay? So the heat is equal to ms delta T, and let's just understand why do we need all these three factors? So the first one is mass. So basically, guys, if you're trying to heat, let's say, 10 grams of water versus 100 grams of water, which one do you think is going to take more heat? Does it take more heat to heat 10 grams or 100 grams of water?
100 grams.
100 grams. So that's the first factor. That how much are we trying to heat? 10 grams, 50 grams, or 100 grams, right? Then the next thing that we need to worry about is this S. So if listen to this one carefully, okay, you can see one conceptual question also on this on your exam. So S here, which is specific heat capacity, guys, what does this signify? So this tells us what are we trying to heat? Imagine this, guys. You're trying to heat water, or are you trying to heat, let's say, aluminum bar? You guys remember? And actually, we did not do that lab this time face to face. But imagine that you have a metal bar. Okay, imagine you have an aluminum piece metal bar, and then you're trying to heat that, and then you also have, let's say, 10 grams of water, and you're trying to heat that as well. So, guys, listen to this carefully. Okay, so I have 10 grams of water, and I have 10 grams of aluminum bar. You're trying to heat both of them on flame. I put them on the flame for 10 seconds, okay? Which one will you prefer to touch after 10 seconds? 10 grams of water or 10 grams of aluminum metal bar?
10 grams of water.
10 grams of water. You see how intuitive that was, that we understand that water actually can take more heat and still not raise its temperature, right? So you see, water is for some reason, water is different from aluminum metal bar, right? So the reason is that the water can store more energy in it, and still its temperature does not go up. And why is that? Is because it has high specific heat capacity.